Welcome, geometry. Here we go with some inductive and deductive reasoning. Want to make sure you guys are understanding what we're talking about. So we have some definitions of what our conjecture would be, how we use inductive reasoning and deductive reasoning based off of our definitions, and just a quick counterexample, which is anything that proves a conjecture false. So the conjecture is your conditional statement. And a lot of times we'll assume it's true, but it can also be false. So it's unproven. If we don't know, if we don't know for sure, we call it a conjecture. And then we're going to use inductive reasoning to look for patterns. Okay? And deductive reasoning is when we're using laws of logic to form a logical argument. Well, that's easy if we know definitions and facts and properties. If we don't, it makes it a little bit harder. But the biggest difference in inductive versus deductive is in inductive, it's all about those patterns. Okay? You see this is happening, this is happening, this is happening, then you can say, oh, I bet this will happen next. Versus deductive reasoning is a man went to the store, he paid cash for his Coke. He received 78 cents in change. Therefore, with the price being $1.19, he paid with $2. That's the deductive. Because you know the change, because you know the cost of the soda, then you can say, I know how much he paid. All right? So let's look at some other examples. Right here in example 1 for some inductive reasoning, it's can we figure out what the next two numbers or pieces would be in the pattern. So if we look from here to here, that's plus 2. We look at the next one, that's plus 4. We look for the next one, that's plus 6. Then the next one is plus 8. So the next one must be plus 10, which means it would be 30. And then plus 12, which would be 42. All right, and I have 3 sides, 4 sides, 5 sides. Well, I better have 6 sides and 7 sides. So please excuse my polygon drawing. It may or may not be up to the standards that you would like. But if I have 6 sides, I'm going to have, a hexagon. If I have 7, I'm sure I have, there we go. And again, sorry about my drawing skills. But you just got to do the best you can, right? And that's why I'd rather you see that I'm not a perfect drawing machine, but I am a math teacher. So hopefully we understand the difference and we're looking for patterns, right? Next up, find a counterexample. The product of two positive numbers is always greater than either number. So remember, product is multiplication. Okay, so, and it has to be two positive numbers. So positive numbers means any kind of number. So I could say 1/2 times 1/4. Those are positive numbers. And when I multiply them, I get 1/8. And 1/8 is actually smaller than both of these numbers. So that's the issue. All right, next one is here. And can we find the value of x squared is always greater than the value of x? Well, okay, so x equals 1/2. So x squared equals 1/2 squared, which equals 1/4. Well, 1/4 is less than 1/2. So that's a counterexample. So therefore, these two statements in numbers 3 and 4 here are actually false. Because we can show one counterexample. I don't need to show 27,000. I need to be able to show one. What if yours is not the same as mine? No problemo. As long as yours is true, we are good, okay? All right? So again, see, 1/8 is less than 1/2, and 1/8 is less than 1/4. So again, false and false because of our counterexamples. All right, last piece, real fast here. Inductive reasoning to make a conjecture about this, and then deductive to show that it is true. So I have the sum of two odd integers. So if I have odd integers, if I have 3 plus 5, it's 8. If I have 5 plus 13, it's 18. Those two sums are even. So the sum of two odd integers is an even integer. That's my conjecture, and I'm pretty sure deductive reasoning it's a definition. Well, I think it has to be true because of our rules. Yeah. And it's also a definition. And look at our next one. The product of an even integer and any other integer. Okay, so what's 2 times 3? 6. What's 4 times 3? 12. What's 8 times 5? 40. Okay, again, the product is even. Okay, and it's based off of what we can show and prove, so therefore that is what we're going to say. All right, now you guys can try your homework.